In this video, we're going to discuss how to actually calculate the probabilities for binomial probability distributions. So the probability of obtaining x successes, this is a lowercase x, that's the number of successes that we want, in n independent trials, so that's our sample size, of a binomial is given by probability of x is equal to n choose x. This is similar to our n choose r. It's the exact same formula. This is our combinations, number of combinations that we have, times our p to x. So we're raising our probability to the x power, times a 1 minus p. So this is the probability that it's not a success in here, raised to the n minus the x. So what this is this is our successes. This value right here is going to be our failures, or our opposite of successes. This is the probability for a success, and this is the probability for a failure. We also have to know some of the notation, math symbols and everything. So anytime that we see at least, no less than, or greater than equal to, we're going to use this symbol. It means starting with that value and going larger. If we just see greater than or more than, say if we say greater than 14, well, greater than 14 is actually going to be 15, 16, 17, and so forth. So we strictly use the greater than. We don't have the equal to. Fewer than or less than, so if we say less than 7, well, numbers less than 7 include 0, 1, 2, 3, 4, 5, and 6. We're strictly using the less than symbol. No more than, or at most, or less than or equal to. We have the less than and we have the equal to sign on there. So let's say that we want no more than 9. What that includes is 0, 1, 2, 3, 4, 5, 6, 7, 8. It also includes 9 because I want no more than 9 of them. So that's actually going to include that 9 with us. Exactly or equals to or is, that is strictly our equals. That is strictly that one value, nothing else. So let's look at an example. According to flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time. So if we're looking at this and we're looking at a binomial, it's either on time or it's not on time. The probability of it being on time is 0.80. Suppose that 15 flights are chosen at random. So n is going to be 15. And the number of on-time flights are recorded. So we're looking for on-time flights. We want to find the probability that exactly 15 flights are on time. So we want the probability that x is equal to 10 because we want exactly. So this is going to look like we have 15. We're going to choose 10 of them. We're going to multiply that by our probability of it being on time, 0.80, raised to the 10th power because that's how many flights we want to be on time, times 1 minus the 0.8 raised to the 15th minus the 10. Well, let's look at some of these to simplify them down a little bit. This one's still 15, choose 10, times, well, 0.80 raised to the 10th power, that's okay. 1 minus 0.8. So if 80% of the time they're on time, 20% of the time they're not on time. And if I want exactly 10 to be on time, I have 15 of them, so that means I'm going to have 5 that are not on time. You will notice that this value and this value in the exponent form adds up to our total n. Also, the numbers in the parentheses, the probabilities, have to add up to 1. When we do this in our calculators, we get 0.1032. So the probability exactly 10 flights are on time is 0.1032. Now let's look at part B. It wants the probability that at least 10 flights are on time. So we're looking at the probability that x is greater than or equal to 10. I want at least. What this indicates is we want the probability of 10 plus the probability of 11 plus the probability of 12 plus the probability of 13 of them being on time plus the probability of 14 plus the probability of 15. And I would do the same formula for each one of these and then add up the values. Well, that's a lot of adding, to be very honest with you. So what we can do is there is a binomial table. It is table A1. It's either in the back of your book or one that I gave you. And you'll notice that we have an N column. That's our first column. We have an X column. The N is the number of trials. So in our particular case, my N was 15. So I've got to scroll down and see where I get N to be 15. And it's right here. Here's where N is 15. Now across the top is our probability. In our particular case, probability was 0.80, which is right here. We originally, in part A, we wanted the probability exactly 10 were on time. So here's exactly 10. 0.103, which if we had rounded to 3 decimal places, would have been the same thing. So we're still looking at this 0.8 right here. Now we want at least 10. So we want 10 through 15. We come here and we add all of these values up. So we're looking at 0.103, a 0.188, 0.250, 0.231, 0.132, and a 0.035. We can add all of those values up to get our probability. So we have 0.103 plus a 0.188 plus a 0.250 plus a 0.231 plus a 0.132 and a 0.035. I add all of these up and it's 0.939. So if I want at least 10, that means I'm going to be doing some adding up. That's where I can use that table to help us out a little bit. Now if we look at part C, recall that my N is still 15. I want the probability between 8 and 10 flights inclusive. What this means is 8, 9, or 10 flights being on time. Well, again, that would be the probability of 8 plus the probability of 9 plus the probability of 10. I'm going to go back over to my binomial table and I'm going to look and I'm going to see, yes, the probability 0.80 is on here. And I wanted 8, 9, or 10. So I wanted these three. So I'm going to look. Here is my 8, 9, or 10. 0.014, 0.043, and 0.103. So I end up with 0.014 plus a 0.043 plus a 0.103, which is going to add up to a 0.16. Now, the biggest thing about this is the table is wonderful if the probability is here, or if our N is here. If I wanted something and it had a probability of 0.85, that's in between here. I couldn't use the table. I would definitely have to go back to the actual formula. We can compute the mean and standard deviation for a binomial as well. The mean is going to be our n times our p. So this is the total number, and this is our probability of a success. That's our mean. Now our standard deviation, recall, is always the square root of something. It's our n times our p. So this is our mean times 1 minus p, the probability that we fail. So let's look at example 3. According to CTIA, 25% of all U.S. households are wireless-only households. In a simple random sample of 300 households, determine the mean and standard deviation number of wireless-only households. So we know that the probability that they're wireless-only is 0.25. So the probability that they're not wireless-only is going to be 1 minus 0.25, which is 0.75. There are 300 households, so n is 300. So our mean for this case is n times p, so it's going to be 300 times 0.25, which gives us 75 households on average are wireless only. Now if I want the standard deviation, I'm going to take the square root of n times p times a 1 minus p. Well, our n, again, is 300. Our p is 0.25. Our 1 minus p is 0.75. And I'm going to take the square root. So whenever I multiply 300 times 0.25 times a 0.75, I get 56.25. And I've got to take the square root of that. So I'm going to take the square root of 56.25, and we get 7.5. So we have, on average, 75 households that are wireless-only households with a standard deviation of 7.5. I'd like for you to practice with these binomials. Practice using the table, practice using the formula, and then practice with the mean and standard deviation. And if you have any questions, please let me know.